Okay, hello everyone. Welcome back. Today we're going to be talking about cluster analysis, and the PowerPoint here is going to be split into two videos. In this video, I'm going to give you a very brief introduction to cluster analysis. What is it? Some of the basic concepts, and then one of the simplest algorithms used for cluster analysis, which is based on these partitioning methods. In the next video, I'll go into also very common methods, but a little bit more advanced. The first one will be the hierarchical method, and then the second one will be model-based methods. And the model-based methods you'll see is pretty advanced algorithm that will basically be using in an applied way using the some of the clustering packages in R. And that will be used to do the lab for this week that looks at trying to cluster all of the census tracts in Phoenix area into specific clusters based on 20 or 30 variables from the census that you looked at in week one. So that's kind of how the linkage will be here in terms of the type of clustering we'll be using for the lab will be based on this model-based method. So yeah, okay, so let's begin. So for those of you who have never even heard of cluster analysis before, this video will be mainly targeted for you. So starting at the very beginning, cluster analysis or clustering or data segmentation is also commonly referred to. Essentially is quite simple. Intuitively, the idea is you have a data set and we want to cluster all of our data points into similar groups or clusters. And the reason why we'll do this is why people do cluster analysis for many reasons, but one of the most important one is to try to reveal hidden patterns in the data that otherwise are not readily visible to the researcher. And the idea behind clustering is no matter what method you use, how simple or complex the algorithm is, the basic idea is the same. All of the data points within the data are going to be categorized or classified into certain clusters based on two features. One, how similarly related they are to each other within that group, and also as a function of how dissimilar they are to objects or data points in other groups or other clusters. Okay, so this cluster analysis is an example of an unsupervised learning technique versus a supervised learning technique. Unsupervised learning, we don't have any predefined classes. We're learning literally through observations by our data. Whereas for supervised learning, if you look at like regression models or OLS, this would be an example of supervised learning. So the clustering analysis is a form of unsupervised learning. And clustering is used in all the fields for different reasons. So in biology, you can make a taxonomy of living things. So you have all the creatures, animals, and species. You can cluster them into specific groups. Information retrieval, land use, marketing. So marketing is a big area in the business econ and economic science, doing market research. Basically using clusters to help to try to detect specific groups of customers. And once those groups are identified, to use that knowledge to target specific groups with different kinds of marketing programs. City planners may also use clustering to identify groups of houses according to their housing type, value, and geographic location. And also in climate research, trying to find patterns of in atmosphere and in ocean studies. Okay, so there's a general, very widely used methods of clustering across different kinds of social science, natural science, and life sciences. So let's take a very simple example on some of the ways that the marketing and economic science might try to use clustering. If we have a very small data set on, say, Costco customers, and we have only two variables on those customers, we have a customer satisfaction variable, which is a question of Likert scale. So ranging from 1 to 9, how satisfied are you shopping at Costco, 1 would be very dissatisfied, 9 is very satisfied. And then the other variable we have is a loyalty score, also for on a Likert scale, 1 being a low loyalty, 9 being high loyalty. So we have this information on a handful of customers. Each red square is a score for the individuals. So we have our customer satisfaction on the x-axis and loyalty on the y-axis, again ranging from 1 to 9. The large red circle is the average score. So approximately 5.05 is the average for customer satisfaction and 5.85 for loyalty. So we have very small data, and we want to use clustering to try to form unique clusters of customers or specific groups within clusters. And so if we are visually just inspecting the data, we might think there's 3 different types of clusters based on their positioning in the data space. That's typically the first step, is just defining where the clusters are, how many clusters there are. In this case, with a very small data set, it's pretty easy to visualize, but you can imagine as we scale up to millions of observations and you have hundreds of variables, it's extremely difficult to maybe just visualize where the clusters are. So we'll need more advanced methods to try to detect different clusters. But in this case, again, we just visually can observe about 3 clusters, or maybe 2 clusters. We can maybe join these together. But in this case, we have 3. So the next step then is, how do we interpret clusters? So for the black circle here, we can see it has very high CSAT score and typically very high loyalty score among most of the customers. So we could interpret this as the customers who are extremely loyal and extremely satisfied with their experience at Costco. The blue circle would be the opposite. So these are customers who are not very loyal and also not very satisfied, or very disloyal and very unsatisfied. And then the third cluster here is a little bit of an anomaly. We have very high loyalty score of customers, but also very dissatisfied at the same time. So loyal but dissatisfied. So if you're in terms of marketing, some kind of advertisement or marketing program, you may want to first target this cluster of customers who you know to be very loyal, but for whatever reason are very dissatisfied. So you would want to try to figure out more information about what makes them unsatisfied. Whereas these guys are very unloyal or very disloyal and dissatisfied. They may be someone you want to target, but in priority, you probably want to target the red circle first. So this is some of the ways that maybe we can use cluster analysis to try to infer information, particularly with bigger data sets that are not visibly obvious, as in this case. And that information can then be used for other kinds of purposes. So one of the big issues with clustering is, as you can imagine, it's very subjective in terms of where the clusters are created. So in our case, we just visualize a few clusters. Would there be a better way to arrange this data into maybe 2 clusters or maybe even 4 clusters? We could split this cluster up, have a cluster of just those 2 extremely satisfied, extremely loyal, and then more of a pretty satisfied, pretty loyal group. So the question always is, how do we compare different number of clusters imposed onto our data? Is 3 the right number of clusters? Is 4? Is 5? Is 6? How many clusters do we need to actually have the most, extract the most information in the most efficient way? Okay, so this brings us into a quality concern. We want to have a clustering method that gives us a high quality number of clustering that allows us to use information and detect some of the hidden patterns in the data. And as we'll see going forward, there's typically a statistic or some kind of separate quality function that we can use to really try to hone in on what the number of clusters are, where they're located, what's the shape of the cluster, et cetera, in order to get a measure of how good our clustering analysis is. With that said, One of the biggest critiques of this kind of clustering analysis approach and other kind of classification schemes like principal component analysis or other forms of data reduction techniques like clustering is that it's really hard to get an objective measure to show us how good or how similar a cluster is. And typically, even with the more advanced algorithms that we'll take a look at, the answer to those questions are extremely subjective. So if you rearrange data and rearrange clusters, it could give you completely different insights into the data, which some may or may not be correct. So it's extremely important to choose your clustering method with care and to also do some quality checks. Okay, so some of the major clustering approaches, we'll take a look at partitioning. It's the easiest algorithm to work with, and it's probably the most common, it's most traditional. Typical methods in this is k-means, k-medioids, and Clarence. We'll also take a quick look at the hierarchical approach, which is a multi-level clustering analysis. And then there's lots of other approaches we're not going to look at today. We will take a very quick look at the model-based approach, which is, again, what we'll be doing for our lab today, which employs some pretty sophisticated algorithms to try to delineate the clusters within data. So moving forward, we'll work with, again, the most traditional, most common, simplest algorithm for clustering based on partitioning method. The idea of partitioning the data into specific clusters is based on this equation, which is essentially the sum of squared distances is minimized between a particular point in the data set and the medioid or the centroid of a particular cluster, okay? So we're just minimizing the distance between every point. So if we go back to our example, the P here is a particular data point, and the medioid of this cluster probably around here. So we're basically wanting to minimize, we want to minimize the distance between all of our points and the medioid of the cluster. And we do that for each, we'll sum that up across each cluster I through K, okay? So this is the basic, simplest algorithm to try to partition your data into specific clusters. We have to define K, so we have to tell the data or tell the algorithm how many K that we want initially, so 2 or 3 or 4. And then it's going to iterate this, minimizing the square distances between the point and the centroid, the medioid of cluster for each cluster, okay? There's different ways to optimize this algorithm. K-means and k-medioids is probably the two most common. And that's where, again, each cluster is represented by the center of the cluster. Okay, so the basic idea is there's a 4-step process to the clustering, partition clustering using k-means. First, well, actually, technically 5 steps. The first step is we have to define K. So we'll put 1, 2, 3, 4, 5, whatever number of clusters you want to impose on the data. And the next step, the partition objects all the data points into each of the cluster. We need to compute the seed points, which is essentially the starting point that is at the centroid of each cluster. And we're going to then assign each data point or object to the specific cluster that has the nearest seed point. And then we're going to iterate that process over and over again until we don't have any more objects being moved from one cluster to the other. And a way that we can visualize this is essentially we tell our statistical software we have 2 clusters that we want to impose on our data set here. And what's going to happen is, in this case, R will arbitrarily partition the data into 2 specific groups without having any centroid calculated, just randomly have all the data points go into each cluster. Then we're going to have based on that partition, we will have a centroid that becomes calculated for each group. So we have our centroid for our R, or for our red colored points, and a blue centroid for our gray colored points. And again, these centroids are based on minimizing the distance between the centroid and the each individual data point. And so we can see that, for instance, this point here, it would make more sense to be placed in this cluster than to being placed in this cluster as it's closer to the centroid here. So then what happens is the points will become reassigned where they minimize the square difference. And again, there will be an updating of where the cluster centroids are based on this new classification. And we will continue to iterate this process over and over again until there is no more change in each data point being placed into a different cluster. Okay, so once everything is all the assignments, all the data points are correctly assigned to the cluster where we can't further minimize the square distance between it and the centroid, then the program iteration will stop and we will have our two clusters, okay, in this case. Okay, so the biggest strength of using this very simple algorithm is it's very efficient. But one of the weaknesses, or a couple of the weaknesses, is that we need to arbitrarily a priori specify the number of clusters, K, and that, especially with bigger data sets, is not always easy to visualize. Okay, so some of the more advanced algorithms, there will be ways that the iteration will automatically select the best number of clusters to fit your data. Okay. The other weakness is that this method is extremely sensitive to noisy data, and especially to outliers that can really have an influence on the shape and the size of the cluster. Okay. So in the next video, we'll go into some of the more also common methods for clustering, but also some of the more advanced methods with model-based methods. And so stay tuned for the next video on that.